Welcome back to the classroom. My name is Mr. Wong, and today we're looking at writing balanced chemical equations. So for this one, we are obviously using a different type of formatting, just because, just to give a little bit of difference. So in today's lesson, we're going to look at how to write balanced word equations, and there are a couple of very simple steps that you need to follow when it comes to writing balanced chemical equations. Okay. So just zooming in a little bit here, we can see when it comes to writing equations, there are four basic stages. So 4 stages of writing a full equation. Firstly, writing out the word equation. Remember, the word equation is an analysis of the actual chemicals. So you write down the name of the chemicals that you're using. Number 2, it says work out the formulae for all the elements and compounds. So for step 2, you'll need a periodic table. Step 3, you write the balanced equation, and then step 4, you add any states that is required. So solid, liquid, gas, or aqueous solution. There is a really simple way when it comes to checking whether or not your equations are balanced. Firstly, check the formula for each element or compound. Are they correct? Okay, as I said again, you will need a periodic table in order to accomplish this. Step 2, only change the number of the molecules that take part in the reaction. Do not change the formula. So what I mean by that, if you actually look at oxygen here, the formula for oxygen is O2. Now keep in mind, this subscript here, unless it's told to you that it is changed, you should leave that number by itself. So say for example, NO3, O3, or CO3, SO4. These are multiple atom ions. You do not expect them to change after the reaction has taken place. But we'll show some more examples if need be. And don't get tricked. If we see this, so this little 2 down here, you can see there, that tells you the number of number of oxygens. So we call that the subscript. But if we put a 3 in front, then we have a coefficient that tells us the total amount of that particular molecule. So say for example, we'll use carbon dioxide as our example here. Maybe I'll try and bold out the pen. Okay, so I'll make it a little bit bigger. This little 2 here, we call it the subscript. So if you recall, that tells us the number of atoms in the molecule. If we write it like so, so we have 3 CO2, this 3 here tells us the number of the molecule. In this case here that we have, just change the color. In this case here we have 2 oxygens and 1 carbon. In this case here, this 3 is multiplied on both sides. So we have 1 carbon, so we have 1 times 3, so we have 3 carbons in total. For the oxygen, we have 3 molecules of carbon dioxide times or multiplied by O2, so that's 2 there. So we have 6 oxygens in total there. So that's how you do the count. Just be aware of that when you do these calculations there. Okay, so let's get to our first example. Our first example is magnesium plus oxygen. So example 1, we have our word equation. We have magnesium plus oxygen, and that gives us magnesium oxide. Remember, when writing a word equation, you want on the same line. I am borderline going too far. So there's that. Magnesium, oxygen, magnesium oxide. The next thing you need to do before you write the equation is obviously work out what the symbols are. So just change it to the periodic table. You will need to be using this as you go. So magnesium is in this position here. Magnesium, the symbol for magnesium is Mg. And then oxygen is in this position here with the symbol O. So I'm going to rewrite the symbol form underneath these symbols here. So we have magnesium, Mg, plus oxygen. It's actually O2 instead of O. The reason being, if you actually look at these elements here, so nitrogen, oxygen, fluorine, chlorine, bromine, iodine, they actually come in pairs. So whenever any word equation mentions oxygen, nitrogen, fluorine, chlorine, etc., you always write it with 2 atoms. So just keep that in mind, okay? We actually call this a diatomic atom. So diatomic molecule, sorry, not atom. So it comes in pairs. All right, so when we combine it, it will become magnesium oxide. All right, so how do we determine this formula? This goes back to writing your or balancing ionic formula. So magnesium, if you actually have a look, is in group 2. So it has a charge of 2+. Oxygen, as an ion, is in group 6. So group 1, 2, 3, 4, 5, 6, or group 16 if you want to call it that way. It needs 2 valence electrons to get to this 8th shell. So it has a -2 charge. If you recall the method of writing an ionic formula, you cross out the charges and you shift the numbers across. So when you shift the numbers across, you get Mg2O2. You want to round it off to the common factor, so round to common factor. And so the lowest you can go is 1 all. So you then go magnesium 1, oxygen 1. But obviously 1s are redundant, so you can then just write it as MgO as the main formula there. So the next thing we need to do is check whether or not this equation is balanced. So on this side, and the easiest way to do, as you can see the diagram, you can draw it out. You can draw out the circles. We can see we have 1 magnesium, 2 oxygens, and then 1 magnesium here, 1 oxygen here. Alternatively, you might want to do a little chart. You write magnesium, we have 1 here, oxygen, we have 2 here. Then on this side, we have 1, and then we have 1 here. So obviously, we don't have enough oxygens. We want to balance out the equation to sort out this issue. Because the idea is we need to have the same number of atoms on both sides. Okay? So what you can do is change the coefficient. So you can change the numbers in front. You can't change the numbers here though. You cannot ever change subscripts. So when I put a 2 here, that means that I now have 2 magnesiums and 2 oxygens. Okay? So the oxygens are balanced. That's awesome. I can tick that off. That's good to go. But I have only 1 magnesium here. So the number I need to put in front is 2. So the ratio I have is 2 magnesiums, 1 oxygen molecule, and then 2 magnesium oxide molecule here. So that's what we're looking at. Okay, so let's go to another example. Obviously, these ones down here, I'll let you figure them out. But let's have a look at scrolling a bit down. We'll just move this bit down and then do this here. Obviously, if you want to see the workings out to that, do let me know. If not, I'll just leave it as it is. So let's look at another example here. So we have task 1, use the diagrams to help balance the symbols, the equations. So we have the sodium. We have 2 sodiums plus the 2 chlorines. And then you have sodium chloride and sodium chloride. So let's try and write a balanced chemical equation to that. So obviously they've already written down the symbols for you, which makes life much easier. Now before I get into the actual balancing component, can you see how these 2 chlorines are bonded together? Well, we actually represent that by the subscript here. So the subscript actually demonstrates the bonding that's happening if it's the same molecule. So the subscript actually shows us that bit there. You can see how the 2 sodiums aren't connected together, so that's why you don't see N2 at the end there. All right, similar idea. So NCl, NaCl, they're bonded together, so you can see they're combined together in this equation here. Okay, so let's just quickly fill this out. I have 2 sodium atoms, so I have 2 groups of them. So if it's 2 groups, put it for my coefficient, because the coefficient tells you how many groups you have. I only have 1 group of Cl, so that's just 1 there. And then I have 2 groups of sodium chloride. Okay, again, this one here is redundant, so I can rewrite this as sodium plus Cl2 plus 2 NaCl. Now if you get really fancy, you want to write the states. So here we have sodium, which is solid, chlorine is a gas, and sodium chloride is a solid there. Okay, so that's solid, that's a gas, and that's a solid too. How do I know this? Well, you can actually tell by looking at your periodic table. So this actually shows you, what it should show you is the standard state you should be able to find it in. So you can see that these colors here, all these sort of grayish colors, that represents the atom being solid in room temperature. You can see how chlorine is this light blue here, so it's a gas at room temperature. So see, so you can see it says it down here for you. The only exception is bromine and mercury. So, you know, that's kind of the idea we're dealing with here. Okay, let's do one more. Let's do example B as well, and then you should be good enough to try the remaining questions. Okay, so we have aluminium. So for this one, we have 4 aluminiums. We have 3 groups of O3, and then we have 2 groups of Na2, L2, O3. So there's that. Now what you need to do, you can either draw the diagrams to depict what you see here, or you can do simply the method I did before, where we actually do the count on both sides. So we have 4, we have 6 oxygens here, and then on this side we have 4 Al, and then we have 6 O. So you can do the counting that way, doing by ratios, or you can draw it out like so. Okay. So the last example. All right, so the last example we need to go through. Oops. Okay, so that ends. Yeah, I know. So that ends our part here. with the balancing equations. There is one more example I want to go through first, though, is what if we balance a group of atoms? So say, for example, we have the ion of sulfate, nitrate, carbonate, hydroxide, and hydrogen carbonate. So you can see how these formulas actually have, maybe I'll just scroll in, you can see how these formulas have really small little subscripts to it. How do we balance the equation under that circumstance? So if we have a look at the diagrams here, so we have a reaction of aluminium with copper sulfate. Now the formula for copper sulfate is SO4. Okay, so that's the actual chemical we're dealing with. Okay, so and then we get the bonding here. So you'll see a really interesting part. So we have Al plus CuSO4. Journey it across, and it becomes Al2 SO4 bracket 3 plus Cu. Now this 3 means we have 3 groups of SO4. Okay, so that's what it represents. When you do balance chemical equations and you're dealing with what we call a polyatomic ion, this subscript here, this subscript cannot change. Subscript cannot change. Alright, so you can rearrange the equation around and balance it, but you can't change this number there. Shows you the example here. So if we have 2 aluminiums, you make it into 2 in front here, and also we have 3 sulfates, so we need to balance it out by having 3 sulfates on this side in comparison to that, and then you have 3 balanced here, 3 balanced like so. Let me maybe show you with one example, or actually let's use the exact same example here to work out a way to balance it out. Okay, firstly, when it comes to balancing equations, let's just write down how many of what we have on both sides. We have 1 aluminium, we have 1 copper, and we have 1 sulfate. Okay? On this side, we have 2 aluminiums, we have 3 sulfates, and we have 1 copper. Okay? So what we want to do first, if we have any issues with balancing, let's quickly look at what we have. Okay, so clearly we have too many on this side, not enough on this side here. Okay, what I'm going to do, you need to firstly work out which one you want to change. I'm going to do aluminium first. 1, because it is a metal, and 2, it's by itself. So you always want to balance a chemical that is by itself first, and maybe it has an odd number of atoms. So to get aluminium to have 2 on this side, we need 2 aluminiums on this side here. Okay, so 1 times the 2 gives us 2 aluminiums. Okay, so now these 2 are balanced. That's all good to go. The next bit we have here, the copper is balanced on both sides, so we don't need to do anything with the copper, but you can see we have 3 sulfates here, and we only have 1 sulfate here. So what I need to do is balance, put a 3 in front here. That gives us 3, and that's now balanced. The last example I have is the copper. Now, because I put a 3 in front of copper sulfate, copper also has 3 atoms now, which means that this copper here must also have 3 in total to balance out the equation. Now that is settled there. Okay? Remember, the golden thing is you can change the coefficient. but you can't change the subscript. Okay, so cannot change your subscript, which is this one here, but you can change the coefficient that is here. So keep that in mind. So that ends the explanation for today. Hopefully you found it useful. Give a like if you want. If not, obviously just enjoy your day and keep staying curious in science.